Today we will revise application of rotation matrices. Here there are two frames, this one and this one. If you rotate this frame around Z by 90 degree, we get this frame. Now here, this one is S frame, this one is body frame. It is at some orientation. This one. Now we are rotating this body frame, this body around ZS cap, that is fixed frame rotation, that is space fixed rotation. So if you rotate this body around, not this axis, around ZS cap by 90 degree this way, anti-clockwise this one, we get this body frame like this, because we are rotating about this cap. So XB cap remains same, this one. So after rotation, after applying rotation, we get this frame. It is called B dash frame. Now this one again fixed frame, this one is body frame. Now we are rotating another way. This one, this body frame in another way about ZB cap, that is body frame rotation, about ZB cap this way. So this way we get this one. This way we get this one, YB cap here, YB double dash. We are rotating ZB cap, so it remains same, and XB double dash cap. In this fixed frame rotation, already body is at some orientation. Then after we are applying rotation about fixed frame rotation, ZS cap. So resulting rotating matrix, we have to take reverse order. R first, then RSB. RSB stands for orientation of body with respect to S frame. R is this rotating vector. So reverse order, and in this case, in sequence, not reverse order. What we have taken? Body frame, rotating matrix for body frame with respect to S frame, into rotating again this one. So sequence is this. Here reverse sequence. What does it mean? If we have RS B dash, that is, if a vector in this frame is given, we can convert this vector in the stationary frame, global frame, using this, that is RS B dash. In this case, if a vector is given in this frame, B double dash, so if we apply this RSB into R, we get a matrix, say RS B double dash. So using this, we can represent a vector in B double dash frame to S frame. So we can apply this way the rotating matrices. Okay. Here is R Z dash cap 90 degree, and here is R ZB cap 90 degree. Done. Here, to rotate a vector V, note that there is only one frame involved in which V is represented, and therefore omega cap must be interpreted as being in this frame. The rotated vector V dash in that same frame is V dash equal to rotation matrix into V, Rodrigues rotation matrix. Now consider these two figures. Initially X dash, Y dash, Z dash at time t. Suppose this frame is rotating about omega cap this way. So after a short while, if you take a photograph, X axis become here, Y here, Z here, this one. So delta theta, this one. This frame is rotating So what about the endpoint velocity? This one. How, at which rate it is changing? Suppose this, now this frame is rotating about this axis, omega cap. Here omega is omega cap into theta dot. Theta dot stands for d theta by dt. So angular velocity is omega cap d theta by dt. It gives direction. So this one is x cap, this one is y cap, z cap. End point of this has velocity x cap dot. Dot means the rate of change of x cap is what? Omega cross x cap. This is one type of position vector, and we know that v is velocity v is given by omega cross r. In the same sense, omega cross x cap. X cap is a position vector 1 0 0. So indirectly it represents instantaneous velocity of this tip particle at time t. Okay.